This is the mini lecture for Chapter 2, the structure of water. Probably one of the first molecules or chemical formulas that you got to know was water, which is H2O. H2O is a molecule, which is a collection of atoms. So H2O has 2 hydrogen atoms, and it's got 1 oxygen atom. Right now, humans are kind of limited, and atoms seem to be the smallest packet of matter that we can possibly investigate. However, we do know that atoms are made up of things called subatomic particles. We've got protons, which we can do P+, electrons, E-, and neutrons, N superscript 0. So protons and neutrons, they like to live in the nucleus. If the protons and neutrons in your body are not in your nucleus, you should seek some medical care or a physicist. Okay, the electrons, they're flying about the nucleus, but it's not random motion that they're flying about. So they contain energy because they're in motion, but it's not random. They're actually organized into things called shells. Shells are not orbits. It's not an orbit like the planets orbit the sun. Shells are like the shell on a malted milk ball like Whoppers or any other chocolate candy that's got a juicy filled center. The shells, there's many numbers of shells, but the shells have some rules. The first shell will only hold 2 electrons. That's all. The second shell will actually hold 8 electrons, and the third shell will hold 8 electrons too. They don't have to hold these numbers, but this is the maximum number of electrons that they can hold. So let's do some examples here. Let's say that this atom here, he's got 1 electron, so that's okay. The first shell can hold 2, but it's only holding 1. That's okay. Let's do this molecule here. Let's give this molecule 2 electrons in the first shell. That shell is full. And then let's give this molecule 6 electrons in the next shell. And that shell is not full. So there's some rules that you got to know about. Electrons, they love to be in pairs. So these lone electrons on our diagram, they don't like to be like that. The other thing that you have to know is that shells love to be full. And again, we've got 2 atoms here that they're not really paying attention to some of these rules. So if you want to know what type of atom that we have at any given point, we can look up the identity of the atom on the periodic table of elements. So the identity of oxygen, which is contained in water, has something called an atomic number. And the atomic number actually tells us how many protons are in our atom. And I'm going to tell you that an atom has no charge. Therefore, if we've got 8 protons, we've also got 8 electrons. And those electrons are organized in these shells that we have over here in this oxygen atom. And that's what we have. Looking at the periodic table of elements, we see that hydrogen is number 1. Using our knowledge about the atomic number, hydrogen has 1 proton in its nucleus, and hydrogen also has 1 electron in its first shell. This electron, though, it's not very faithful. It looks at its proton. It's like you're just 1 proton. There are so many atoms out there that have so many more protons than you. What am I doing? What am I staying for? So let's give this little electron an A. That was a story. That's not a personal experience that I just said there. It's just a story. Okay, so finally, right? Subatomic particles make up atoms, and then atoms, 2 or more atoms make up a molecule, and water is our molecule. What's holding the atoms together in our water molecule, though, are this pairing here, right? And these pairings here, these are called covalent bonds. Covalent bonds are very, very strong. They're difficult to break. And covalent bonds are made by the sharing or pairing of electrons. It's like hand holding. If you've ever seen that episode of Family Guy where Stewie and Brian, they kind of get their hands stuck together by this really strong glue, that's a covalent bond. They had a covalent bond all week until they could get the remedy for that. What happens, though, in a water molecule is that the electrons, I mean, again, they're like, oh, hey, you are just 1 proton. And you are that's not very much to keep me here. So the electrons, they end up having this like red hot party down here by the oxygen nucleus, right? So all of the electrons tend to gather around where a majority of the protons are. It's like an electron party. What this does is this creates a structure that's known as polar, or having poles. Since we have so many electrons down here, we have a slightly negative charge. And since we don't have very many electrons up here, but we do have protons in those nuclei, we have a slight positive charge. This creates a molecule that is called polar. A molecule that is polar exhibits, wait for it, polarity. Polarity is having charges, either positive or negative. Opposite to polar molecules, obviously, are, wait for it, nonpolar molecules. Nonpolar molecules have no charge like a block of wood. I want to mention here that students have a great misconception about polar and nonpolar. Many times students think that polar molecules, like Mickey Mouse over here and water, many students think that polar means positive and that nonpolar means negative, and that is not true. Polar means having a charge, whether that charge be positive or negative or having both, like water does down here, right? And this positive and negative charge, what it really results from is from an unequal sharing of the electrons in the covalent bonds. And what that does is it creates these poles and gives the water polarity. Nonpolar molecules over here, like Princess Leia, nonpolar molecules have no charge and thus are like a block of wood. I'm kidding, not about the block of wood, but about Princess Leia. This is actually carbon dioxide, and what you've got here is you've got carbon and 2 oxygen atoms, and they are also sharing covalent bonds. However, these are not polar covalent bonds. So oxygen has this property of non-polarity. So does carbon dioxide and some of the other molecules, especially these 2 that we know of for breathing. Think of all the things that you know of that are polar. Anything that you know that's polar is water soluble. So what do you eat at night? Rice, bread, pasta, anything starchy, right? Towels, cotton, linen, all of these things, they absorb water. Things that you know of that are non-polar are things like oil, wax, right? Oil and water don't mix. One great invention I think of is Gore-Tex, which is made out of rain gear, right? So there are lots of examples of non-polar and polar substances in your life, and especially 2 examples of non-polar are the gases that you're exchanging right now in your lungs. What this polarity does, though, so let's draw our Mickey Mouse molecule just to remind ourselves. What this polarity does is it creates the positives slightly up top and a slight negative charge down below. And hydrogen molecules, what they can do is they can bond together from attraction, that positive and slight negative. And this is what is called a hydrogen bond. Hydrogen bonds are very, very weak. And you would think to yourself, well, why do I need that in my body if they're weak? I don't need that. You have a majority of hydrogen bonds are easier to work with because they are so weak. They're easier to break. They're easier to reform. And if you think about your own body, you are definitely not the same as you were 10 years ago, 15 years ago, and many of you may not have been born longer than that, but any time before that, right? Your body has changed so much. And actually, if you weren't made of many hydrogen bonds, your body would be dealing with these covalent bonds that are very strong and very difficult to break, right? And you would spend your entire life trying to consume energy, trying to get enough energy so that you can manage, break, and build up those covalent bonds. So you would basically be like a cow, just eating and eating and eating. Or like my husband, who, yes, at the age of 43, definitely has the metabolism of a 17-year-old or a cow and eats all the time. Okay, other than that, we're going to look at hydrogen bonds in the next mini lecture because we're going to see how hydrogen bonds, they lead to this, all of these really versatile properties of water and how water really supports life on this earth.